All right, here we go with example 3. It's on page 622, and we're adding and subtracting. So here we have the square root of 45 over 4, and we're going to subtract the square root of 5 over 3. So just like any normal subtraction problem that involves fractions, because that's what we have here, we have fractions, we have to have a common denominator. So you're going to multiply both of this side times 3 so that we get a common denominator, and both of this side times 4 so we get a common denominator. So you're going to have 3 times the square root of 45 over 12 minus 4 times the square root of 5 over 12. Okay. Hold on, what did I mess up? Oh, then we're going to factor this out, all right, because we have 45 under here, and we can take a perfect square out of this. So let's do that. 3 times square root of 9 times square root 5, okay? Square root of 9 is 3, so that's going to give us 3 times square root of 5, so 9 square root 5. So now we will have the same root and value under the radical sign. So we have 9 times the square root of 5 over 12, because this replaced this, minus 4 times the square root of 5 over 12. Now we can just subtract like a normal fraction subtraction problem. 9 minus 4 is 5, so we're left with 5 times the square root of 5 over 12. Okay, let's do B. B says cube root of 7x over 8 plus 2 times the cube root of 7x. Okay, so let's rewrite our square rooted fraction here as, or cube rooted fraction here, as the cube root of 7x over the cube root of 8. And now we have plus 2 times the cube root of 7x. Okay, so cube root of 8 is 2. So now we have cube root of 7x over 2 plus 2 times the cube root of 7x. Well, we can't really add them like this. We have to have a common denominator. So what we're going to do is we're going to multiply this one, because technically this one is over 1, right? We're going to multiply the top times 2 and the bottom times 2, and that's going to give us 4 times the cube root of 7x over 2. Okay, well now we'll just cross that out so we can work on it this way. Now we have roots that are the same and values under the radical that are the same, so now we can just add. So this is actually a 1 value, right? Because there's nothing there, and when there's nothing there, it is a 1. So we have 1 plus 4 gives us 5 times the cube root of 7x over 2. All right, go ahead and press pause, please, and do practice 3, A and B. Okay, so for A, we have square root of 28 over 3 minus square root of 7 over 4. And we want to subtract these. We do not have the same thing under the radical here, so let's see if we can pull out, we can simplify this in any way and pull out a perfect square. So we do have square root of 4 times square root of 7, right? 28 over 3. And we can pull that out, and that will go to 2 times the square root of 7 over 3. Okay, so we can replace this with 2 times square root of 7 over 3. Let's rewrite this here. 2 times the square root of 7 over 3 minus the square root of 7 over 4. So our roots are the same, but we don't have a common denominator, so we need to get that. So multiply this side by 4 and multiply this side by 3. And our new equation is going to read 8 times the square root of 7 over 12 minus 3 times the square root of 7 over 12. And now we can subtract like a normal fraction problem. We have 5 times the square root of 7 over 12. Okay, look at B. Oops. For B, it is just like the example we just did. You should end up with 13 times the cube root of 6y over 4. Okay, let's let me see how much time I have. Oh, I can explain that one. Okay, so this is the answer. Now we need to get to work the problem to get this answer. This is your answer. We had cube root of 6y over 64 and plus 3 times the cube root of 6y. Okay, so you're going to rewrite this here as cube root of 6y over cube root 64 plus 3 times cube root 6y. All right, so what is the cube root of 64? It's 4. 4 times 4 is 16 times 4 is 64. So our cube root here is 4. So we have cube root 6y over 4 plus 3 times the cube root of 6y. All right, so our roots are the same and what's under the radical is the same, but we don't have a common denominator. So over here, it's 1, right? So you're going to multiply everything over here by 4, and that will take you to 12 cube root 6y over 4. So now you can add these, and if there's nothing here, remember that's a 1. So you end up with adding 1 plus 12, which is 13, cube root 6y over 4. That's how you got there. All right, let's do example 4. All right, so now we are going to distribute and FOIL using roots. Okay, so we have square root 3 times 5 plus square root 30. So treat this just like any other algebraic problem that you're going to distribute. You're going to distribute the square root 3 here and here, okay? So to do that, we would say, what's 5 times the square root of 3? Well, that is 5 times the square root of 3, okay? And then here, square root of 3 times the square root of 30 would be square root of 3 times the square root of 30. Since we're multiplying, and we're not adding or subtracting, since we're multiplying, you can multiply underneath the root sign, as long as the roots are the same. And they're both square roots. One's not a cube and the other square. They're both square roots. Okay, so you have 5 times the square root of 3 times 3 times 30 is 90. This can be broken up, simplified rather, into square root of 9 times square root of 10. So what is a square root of 9? That's 3. So we would have 3 times the square root of 10. Oh, sorry, this is a plus sign here. All right, so now we have 5 times the square root of 3 plus 3 times the square root of 10, and that's as far as you can go. Okay, let's look at B. B, we have square root of 5 minus square root of 6 times square root of 7 plus 1. So this is just your standard FOIL problem. First, outside, inside, last. So our first would be square root of 5 times square root of 7, which is going to give us square root of 35. Our outside is going to be square root of 5 times 1. And both of those are positive numbers, so it just stays square root of 5. Our inside is going to be the negative square root of 6 times the positive square root of 7, which gives us a negative square root of 42. And our last is going to give us a negative square root of 6. So we're finished here because nothing can be broken up, nothing can be simplified, nothing can be combined. So that's it. All right, look at C. C says 7 times the square root of x plus 5 times 3 times the square root of x minus the square root of 5. All right? So we're going to treat this just like a FOIL problem. FOIL. All right, first, we have roots that are the same and values under the radical that are the same. So what we're doing here is just multiplying. So we have 21 for 7 times 3, but now look at this. We're it's the square root of x squared, right? It's the square root of x, and we're squaring it. So that just goes away. So we actually have 21x because it cancels out. Now let's look at the next one. Outside, we have 7 times the square root of x times the square root of 5. So here, we're just going to multiply. So we have, and then it's negative, because here's your negative sign here, 7 times the square root of 5x. And on the inside, same thing, both are positive, but we have a 5 and a 3 and only one radical. So 15 times the square root of x. And for our last, we have 5 times the negative square root of 5. So minus 5 times the square root of 5. All right, so other than simplifying this one right here, nothing else can be simplified anymore or combined. So you end up with 21 minus 7 times the square root of 5x plus 15 times the square root of x minus 5 times the square root of 5. All right, let's go on to D. D says 4 times the square root of 3 minus 1, and we're going to square the whole thing. And you should remember from Algebra 1 and 2 that when you square a value like this, you can't square each individual thing. You have to write it out multiplied by itself. Okay? So now we're just going to use FOIL. All right, we have 16. Now we're squaring the square root of 3, right? So we just have, that's just 3. So 16 times 3, basically. Now let's do our outside. And it's negative because this is negative. So we have 4 times the square root of 3 times negative 1. And our inside, it's also negative. And our last is a positive 1. So what we can do is we have two values right here we can actually combine. We have negative 4 times the square root of 3 minus 4 times the square root of 3. They have the same root and the same value under the radical, so we can combine them and we can multiply this. So we have 48 minus 8 times the square root of 3 plus 1. Okay, well, we can add that one over here, so we actually have 49 minus 8 times the square root of 3. Final answer. Okay, let's look at E and F. How am I doing on time? Okay. All right, so for E, we have square root of 2x minus 5 times square root of 2x plus 5. Our standard FOIL problem. Okay, so let's FOIL. Square root of 2x times the square root of 2x. We are squaring the square root, so we are just going to end up with 2x for our first. Our outside is going to be plus 5 times the square root of 2x, and our inside is going to be minus 5 times the square root of 2x, and our last is going to be minus 25. All right? So, put it together. These two cancel out. Positive 5 times the square root of 2x and negative 5 times the square root of 2x. Those cancel out, so we have 2x minus 25. And for F, we have the square root of x minus 3 plus 5 squared. So we're going to rewrite this as the square root of x minus 3 plus 5 times, right, itself, the square root of x minus 3 plus 5. Now we're going to FOIL it. All right, first, outside, inside, last. All right, so we're squaring the square root of x minus 3. So that cancels out. So we have x minus 3. Our outside is going to be 5 times the square root of x minus 3, and our inside is going to be 5 times the square root of x minus 3, and our last is going to be 25. So we have something here we can combine. So we have x minus 3 plus 10 times x minus square root of x minus 3 plus 25. Okay, well we can combine this right here so that we just end up with x plus 22 plus 10 times the square root of x minus 3. And that is your simplified answer. Okay, please press pause and do practice 4, A through F. All right, answers to A through F. A, you should get 2 times the square root of 5 plus 5 times the square root of 3. B, you should get 2 times the square root of 3 plus 2 times the square root of 2 minus the square root of 30 minus 2 times the square root of 5. C, you should get 6z plus the square root of z minus 12. D is going to be negative 6 times the square root of 6 plus 15. For E, you should get 5x minus 9. And finally, for F, you should get 6 times the square root of x plus 2 plus x plus 11, and they can be in a different order. Okay, so that's it for this section. I will put the homework assignment up on Google Classroom, and then next week we'll start chapter 11. Have a great weekend.